Okay, this is Screencast 1 for our unit on pressure, and concept 1 is fluid pressure. Consider the following. Have you ever used a bicycle pump before? What happens when you pump air into a bicycle tire? Well, the word pressure comes from the Latin word meaning to press. So when you apply pressure to something, you're pressing on it. Have you ever blown a balloon before? What happens when you blow air into a balloon? Well, as you add more air to the balloon, you're increasing the air pressure. And as the balloon gets bigger, the pressure gets higher and higher and higher. Inflating a basketball or a football. We've done that before. A couple steps. First thing that happens is air inside the ball pushes against the sides of the ball. As you add more air, this increases. The more air you put into the ball, the more the molecules push. The pressure goes up as we add more air. So more air equals more pressure. And this is also true with tires, also air mattresses, and anything that's inflatable. Oh, there's my Patriots joke, a deflated football. Because we know what happened with the Patriots. Tom Brady deflated a football by taking air out of the football and lowering the pressure. And there we have some balloons, some happy balloons. Okay, now why fluids exert pressure? Pressure always moves from areas of high to areas of low pressure. High to low, that's how pressure works. Example, popping a balloon. You have a balloon, and I just did a YouTube video, and one of the 4 demos involved popping a balloon. So definitely head over to YouTube and check that out. So you have a huge balloon, and there's a lot of air inside, the pressure is high, and as you pop it, all that air goes from the high pressure inside the balloon and leaves the balloon in an instant, causing that loud pop, giving kids heart attacks. There's a diagram from the book showing high pressure and low pressure. Of course, we should never puncture a basketball. No, never. Maybe a soccer ball, never a basketball. Okay, there's 2 factors that affect pressure, and they'll show us an equation on pressure. Factor 1, force. Factor 2, surface area. So force and surface area are the 2 things that contribute to the pressure. The equation is pressure equals force divided by surface area. Force over surface area. So these vary inversely because as the one goes up, the other goes down. So as you decrease the surface area, the pressure gets bigger. And as you increase surface area, the pressure gets smaller. We're going to talk about that in a minute here. So some really good examples. Example 1, a balloon and a push pin. If you take a balloon and you use the pointy end, it pops right away with very little force applied. But if you were to flip the pin and try to pop it with the non-pointy end, a lot harder because the greater surface area. Greater surface area decreases the pressure. People on a frozen lake, virtual demo. If you're on a frozen lake and you hear the ice cracking around you, and you're in the middle of the lake, what can you do to decrease the pressure? Answer, you want to increase your surface area. How would you increase your surface area? You lay flat on the ice, spread yourself out, and that's going to lower the pressure and give you a chance. Give me a call. I will come and save you if you're an Eagles fan. And also an egg squeeze. It's impossible to break an egg squeezing it in the palm of your hand because your hand has a lot of surface area. So you don't have enough pressure to break the egg if you do it right. And again, that's demo number 3 on my video clip. So I encourage you to check it out. And you see I'm working really hard in that picture to try to break the egg, and I could not do it. Okay, units for pressure. There's 2. The SI unit is the Pascal, named after Blaise Pascal. And the English unit, which we're more familiar with, is PSI, pounds per square inch. Okay, calculating pressure. You want to use a pressure equation. There it is. How much pressure is exerted when a 10 Newton force is pressed over an area of 5? Well, use the equation. You take 10 over 5. Answer is 2. Next one. How much pressure is exerted when 25 newtons of force is pressed against an area of 5? Again, you take force over area, answer 5. These equations are very easy. Very easy. Okay, here's a question. How can someone use snowshoes to walk on top of the snow? Let's say we have a blizzard and we get 3 feet of snow. How can you walk on top of that snow? And how is it possible for a magician to walk across broken glass in bare feet without getting cut? Good questions. Well, to answer the snowshoe question, or the snow question, you have to wear special shoes called snowshoes that, if you look at this shoe here, the area is over 4 times greater than a normal shoe. Again, bigger surface area, less pressure on the snow. So you can walk across snow because you have less pressure using these big shoes. And there we have a bed of nails. Stepping on 1 nail will be very bad. Stepping on 2 nails, very bad. Nail goes right through your foot, in one side out the other. But stepping on 1,000 nails increases the surface area, decreases the pressure. And we'll be talking about that in a future lesson. Thank you for watching, and I'll see you in class on Zoom.